What's going on YouTube? This is Ipsac, and we're doing Intense from HackTheBox, which was an extremely challenging machine, which is surprising when you combine it with the fact that there's really no surprises. That author didn't try to hide anything from you. Pretty much every step along the way, they provide you the source code for you to analyze and figure out how to do it. It starts off with a web application that has two vulnerabilities. The first one is a SQL injection in a SQLite database, but the way it's coded makes SQLMAP not really work. And even when you try to manually exploit it, it has some difficulties because of limited character space. And then once you do a SQL injection, you'll have difficulties actually trying to crack the hash because it's not crackable. It's vulnerable to a hash extension attack, which lets you trim off a piece of the secret at the beginning of a signed message if it's signed improperly, and just let you re-sign the message. It's a really cool attack. I don't fully understand it, but we'll do it. And after all that, you get access to the admin of the web page that lets you read files and list contents of a directory. You get a private SNMP string that allows you read-write privilege that lets you get code execution, get a shell on the box, and then find out there's a buffer overflow for the root. So with all that being said, let's just jump in. As always, we're going to start with the nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it intense, and then the IP address, which is 10.10.10.195. And I am going to run nmap with sudo because it always runs better with sudo. I explained it in some other videos, but just take my word for it and run sudo with your nmap if you're not root. Looking at the results, we have two ports open. The first one being SSH on port 22, and this tells us it's an Ubuntu server. We also have HTTP on port 80, and it's also telling us it's Ubuntu. And we also have Nginx, which doesn't really mean all that much, but I generally don't see too many PHP web apps on Nginx. For some reason, normally that is just going to be Apache. That being said, I'm pretty sure HackTheBox is on Nginx, so take that with a grain of salt. Just something to keep in mind. Now, this box is unique that it does have something listening on UDP that becomes important later on. You don't have to do UDP scans all the time, and I'll show you how I found out this box had UDP listening once we get to that point. But if you're super diligent about your scans, you could do a -su for UDP. We can add -v and then do 10.10.10.195. And this does require root privilege. And I don't like scanning UDP that much because nmap is kind of flaky, telling us what ports is open and what is not. If you wanted to, you could add -oa nmap UDP. And we'll just let that run and come back to it. So it had a website running, so 10.10.10.195, and we just get this intense web app. We could try like /index.php to see if it is a PHP app, and it isn't. I don't know exactly what it is. I think it was Python, but we'll find out in a second. Click on home. We don't have anything. It says you can log in with username and password of guest. So I'm going to try guest, if I can type guest that is. And it says you are logged. Forgot to say logged in, but we get in here and the only thing new is this submit form. So I'm going to submit the form test and we say your message has been sent. And it brings us back here. I'm going to switch over to Burp Suite, and we're going to intercept this message and see what we have. So on my proxy tab, intercept is on. We're going to say, please subscribe, send this message, go over to Burp Suite, and send this to repeater, and we just get the message OK. So the very first thing I do whenever I have an endpoint that is authenticated, which means this submit page, I needed to be authenticated to hit it, or at least see it. I don't even know if I have to be authenticated to hit it. We can test it out real quick. So I'm going to change this request method to be a get. We're not going to send anything. And we're just going to say, what was it, /message, I think? Is this? /submit. So we get the submit form with this, where it says like send feedback message. So looking at the bytes, it's 4288. Hit it a few times, the bytes doesn't change. I'm going to get rid of the cookie, 4166. And it's going to probably say, wait. What is different when I send the cookie and not? Does it say like logged in as guest or something? Now I'm actually curious. Let's see this. But what I'm getting at is whenever you have authenticated endpoints in an API or a website, you should try just hitting them without being authenticated to see if you actually need to be authenticated. Sometimes you'll see that the authentication just gives you the link. So let us refresh this page. Oh, Burp Suite is off. Turn it on. Refresh the page. Get rid of the cookie and see what this says. Send feedback. There must be something in like the source code that says guest or something, but not gonna spend too much time on it. Looks like you don't need to be authenticated to hit this, only see the link. So that's pretty cool. It's gonna come in handy when we try to fuzz this endpoint because we can get OK here, and then taking that out, we also get OK, so we don't have to send our login cookie with our fuzzing. So we could manually fuzz this and figure out what it is, such as just putting a single quote makes it error. We could do a single quote and comment, incomplete input. So chances are this is going to be some type of SQL. However, the way I like fuzzing it is just using a tool called FFUF. And now I'm using FFUF because HackTheBox has a course on it. I used to use WFuzz for all the things, but now I switched over to FFUF. And we'll show why if you go to the HackTheBox Academy. It's a tier 0 module. So if you just go to modules, all modules, tier 0, and you can sign up for the, did I click tier 0? Tier 0, attacking web applications with FFUF. So you can sign up for this course for free and go over it and learn all about the tool. That being said, we're just going to do it manually. So I'm going to run fuf-u http 10.10.10.195/submit message. And this is the endpoint I want to hit. And then I'm going to use the word list, opt, seclist, fuzzing, special characters. So that's going to go through this whole word list. I'm going to tell FFUF that I want to do a post request. I don't know if I have to since I'm specifying data as well. Just something I want to do. And then -d, this is going to be the data portion. So this portion of the message right here. So I'm just going to say message is equal to A and then fuzz. And whenever it sees fuzz in all capitals, just like WFuzz, it's going to replace everything in this word list with fuzz. And then the next thing we should do is, I think, that may be it. We can run this. And let's see, did that work? I'm expecting to have to do something with the content header. We didn't get anything. So everything says size 200, size 2, words 1, or status 200. And when we were manually poking at it, we put a single quote, and we got a different size and more words. If we look at the single quote here, it still says size 2, words 1, lines 1. So whenever you do something like any type of fuzzing, you should be able to find a way to identify that you're actually fuzzing correctly, and it's not just giving you something. So let's send this over to Burp Suite. So I'm going to do a -x, and we will say http://127.0.0.1:8080. And we can clear the proxy cache, go in, and I'm going to forward the request until, actually, we can forward them all, and then just go in HTTP history and find the one with a single quote, which is right here, and go to the response, and it says OK. So I'm going to make this, send it to repeater, and we can look at these two requests, and this one with a single quote, I'm going to copy, paste it here to make sure this is the same exact thing. And it's saying okay and not here. So at this point, I look at all these headers. And going back to this, there's not many. It doesn't have a content type header. So let's go and add that to tell the application what type of content it is. And like we're going to say application URL form encoded, which is this. There's also like JSON, which would turn this into a JSON message. So JSON would be something like message : I wonder if that's going to work. that would be kind of like a JSON. Says okay. Huh, that actually works. If we do a single quote with A, okay, doesn't. I could be doing that piece wrong. But the key piece, oh wait. I did not change this to be JSON. Okay. Okay, that doesn't work. You want to test yourself, always just try writing like JSON and everything by hand on the fly. You'll find out you'll make mistakes just like me. And maybe the application doesn't even support that. So not going to spend too much time playing with that. But the key thing is we just add this header. So I do the -H flag, and we can say content-type, specify application form encoded. And now when we send this, we do have one thing. So with FFUF, it changes how you do these filters a little bit. So we can do FFUF-H, and we can see it's got a match and a filter. Filters essentially hide, match is match. So we can do filter, let's see, response size, FS. So if we run this again, we can do -FS1, or probably FS2 to hide size 2. And we do that, and we only get one request back right here, the single quote. If we did match size 2, we get everything back. So yeah. So we have a single quote causing some weird things. So at this point, we probably should throw this into SQLMAP because it's a SQL injection. It makes sense to throw it into SQLMAP. So I'm going to copy request to file, and I'm going to say message.request, and we can do SQLMAP-R message-request --batch level 5 risk 3, and this is just going to take a while to run in the background. And we can go and manually poke at this SQL injection. And yes, I know if we went to the actual website, it says this app is open source, and there's a link to download the source code, which we'll do in a bit, but I always like doing as much blind as I can so I can figure out how to enumerate applications that I just don't have the source to. So again, we do a single quote and we get this error message. So the main thing I'm curious about is like why when we do a comment, we get incomplete input, because this should end our injection. So that is unique. We could try like and this to see if we can do anything. So what I did was I turned the statement into something A, and we put the ending quote there and A, and then the system put something here and does something afterwards. So we know we can do this. So we can enumerate what type of database it is. And unrecognized token, I know is a SQLite error message, but we could try like and DB name or something. This is a MySQL function, and we get no such function. So we know this is not MySQL. And based upon all the error message we're getting, we know it's SQLite. Like if you had Googled unrecognized token, I think SQLite's going to be the very first thing. So let's do database and paste this just to see what we get. And yeah, SQLite. So that's just a way to identify what database you're in. So the next piece of this is to try to extract data. And it doesn't look like we get any output back. Like if we do a valid query, it just says okay. So there's nothing for us to do a union injection into. So that leaves Boolean injection. So we can try to do some type of Boolean injection. So let's try a case statement that supports if then. So we can do and case when, and I'm putting everything in caps when it's SQLite syntax type thing. I don't think it's case sensitive. So when 1 equals 1, then 1, else 2, and then we have to do a, this should be this, and else, and A is equal to A. So we have this, and if we change this query, right now they're both going to accept. So we have to change one of these to be an error message. And we can do else, maybe db name. Let's see. It's always going to error when we do this because this function doesn't exist. So we have to do a function in SQLite that we just don't have permission to do, which we could do load extension. So now this is a 100% valid SQLite query. And on this else, we get we're not authorized to do load extension. So now we have a good way to do Boolean injection. So let's go back over to our SQLMAP, and we see it's still taking its sweet time. So let's quit this and try to speed it up. So let's say the parameter is going to be message, so -p, and we say inject into this. We can say -- technique is equal to B, which is Boolean. I think it's BEAUST for all the techniques. We want B. --dbms is equal to SQLite. And when we run this, it's not going to find it at all. And I don't know exactly why the case is where SQLMAP doesn't find it. And it's taking forever. Did I do it correct? I didn't think it would take this long, but... Oh, because I have level 5 still. So I have these, so it's still taking its sweet time. I think SQLite's just not great at... SQLMAP's just not great at doing SQLite. So I'm going to show the one really bizarre thing I saw that I thought it would detect Boolean injection. So we can say, what is it? -- proxy is equal to http :// localhost 8080. And we go over to our proxy. We can see SQLite's request. And we can see some here from SQLite changing the size or changing the length. And if we look at the response, we get syntax errors. So I would think it would know to go more into some type of Boolean injection, but maybe because it's syntax error and not saying invalid, it didn't work. SQLMAP also has a -hh, which will give you advanced help. And I think it's --string. Will match when the query is evaluated true. So we could also try adding that --string to be okay to help SQLMAP know exactly what a true statement is on that Boolean. And then finally, what we could do is help SQLMAP even more and go into our repeater, copy this, and let's go into, what do we call it, message.request. We can change this. And whenever you put a star in the request, that's telling SQLMAP where to inject. So we can inject into this, right where the Boolean is. And let's see, instead of -p message, we'll just get rid of it. And it tries to inject right there. Let's do the -- proxies to show you exactly that's what's happening. Host 8080. There we go. Go over to Burp Suite, go to the proxy history. Oh, we're getting message too long now. So maybe that's why. So there is something after 140 characters that it will say message too long. So maybe that's breaking SQLMAP. But I just wanted to show all the playing around with SQLMAP trying to get it working, and it never works. So that's why we go this manual route. I'll be really curious to read all the write-ups to see if anyone got SQLMAP working. But we can do statements here. So if the statement is true, it's going to work. If we do 1 equals 1, you get OK. If we do 2 equals 1, you get not authorized. So we can try select count username from users where username like, and I'm just going to put a wildcard here. And we're going to close this, and we have to do another one. And we'll say greater than 0. We get OK. I'm going to put please subscribe here, and hopefully we get an error message. We get, oh, message too long. Ooh. Please. There we go. Not authorized. So what we did here was, let me copy this into a terminal so we can kind of break this down and make it more readable. So we'll just call it help. So what we did, we have this and, then this turns it into a case when, and then we got this select count username. And when that is greater than 0, then this is going to say OK, else load extension end. So the reason why we did count is if we just did username here, we'd have to try to brute force the entire username, I think. Or no, we'd have to put the username in this piece. And we're going to do that when we go and try to break this password. But the count is just saying, hey, show me, like, it's either going to be 0 or 1. Or I guess it could be like 4 if you did like, probably, where username like this, it's probably going to be like 3 users or 2 users. So we can play with this a little more. But this is going to return how many users there are. And as long as there's 1 user, it's going to say OK. So that's what I'm trying to explain there. So let's see. Let's do this %. So we can do greater than 1, says OK. Greater than 2, says not authorized. We do equals 2, though. It says OK. So we know there's 2 users. One is probably going to be guessed. So I'm going to hit G %, and we get not authorized because there's only 1 user that begins with G. So we can just do equals 1 or greater than 0. So G-U-E-S-T. Sweet, we got the very first user. We put something after this as not authorized. But the next one, we can begin with A. And as soon as we do this, you can probably guess what the user would be. And the user is going to be admin. And we can do an I to see if it's administrator. It's not, so it's just admin. So from this SQL injection, we know the first user on this is admin. So let's try extracting his hash. I'm not used to that actually ask me a question. This will be user. Like when I hit this, it's like, what do you want, a WebSocket or HTTP? That's new and Burp Suite. But just Control-R, this one's going to be password. So there's a few ways we can do the password. I'm going to explain it the first way, how we're going to do it in the script, and then we'll show a way you can potentially optimize how you're scripting it if you want a real challenge to go fast. But when we do the brute force, it's going to be this way. So here again, we can do queries. So we can say select, what is it? Actually, let's clear this and rewrite it. So I'm going to go like this. There we go. So let's just write the query here and then we'll go back. So it's select, and we're going to guess secret from users. And I got this piece from analyzing the source code. And we're going to do that when the time comes. But yeah. So select secret from users, limit 0, 1. And that's going to grab the very first user. We could do where username, like, or is, whatever. But whenever I do this type of stuff, I always like doing it in numbers Because if we said where a user is, then it's going to be harder to script to enumerate everything. If we did it with this limit statement, we just have to increment this number by 1, and we move to the next entry in the result. So it just makes it more script friendly. So that's why I like doing it that way. So we're going to do like that. And we'll have to say like that. Yeah. So this is going to grab the secret from users, the very first user, which is probably going to be admin. It could be guest, but generally the very first user in a database is always admin. And like, just like how we did the username. So let's put this all on one line. And we have a syntax error. There we go. I had too many parentheses. So we could brute force this and see if we get it. D, E, F. So now we know this does work. So I'm going to change it up and show you how you can do some little optimization. But we're not going to do this in the script because it would probably add another like 15-20 minutes to the video to do it. But we can say substring this. What is it? I'm just going to retype the whole query because it's a pain to edit queries. So we can say UNICODE substring select secret from users limit 0, 1. And now we're getting out of this, and we can say 1, 1. I think this is it. So what this piece is doing right here is it's going to extract the very first character of the secret. And then what this piece is doing is it's going to convert that into a Unicode character. So that's going to allow us to like do greater than less than. So if we have like the very first character can be 1 through 100, instead of sending a web request 1, 2, 3, 4, we could send a web request like, is this greater than 50? Okay, it's greater than 50. Is this greater than 75? Okay, it's not. So now within 2 requests, we took that 100 character key space and turned it down to just 25. So hopefully that makes sense. Put these here. I think I put a extra semicolon parenthesis somewhere. Like that. And I don't know if it has, let's see. It's less than, do we have a number here? 0? Let's see. I have an error message somewhere. Probably only needs 1 parenthesis. There we go. So we're saying not authorized. If we do is greater than 0, it says okay. We know the very first one was F based upon the previous thing we did. So I'm going to do man ASCII, and we can look for F, and the Unicode value for F is 102. So I bet if I do greater than 100, it's still going to say okay. If I say greater than, oh wait, that's 0 there? 100? There we go. Change it to 200, not authorized. So we could go, okay, now is it greater than 110? Nope. So it's between 100 and 110. And then you could have the logic of your script go, is it 100? No. Is it 101? No. Is it 102? Yes. Okay, we know the very first character is F. So that is the way to do it optimized. Of course, we're not going to do optimized because that's going to be a huge pain in the butt to script. So I'm just going to do it this way. So let's copy this request, and we're going to go into Python and create a thing to get a password. So I'm going to do get pw.py, and let's see. The first thing we do is import the request module because we're definitely going to want that. And then let's create a function called checkResult, and we're going to have guess. So this is going to return true if the application says OK, essentially. So payload is equal to F, and we'll paste this. And right here, this is going to be the guess. Okay. It's just weird how my line wrapping is. There's not a blank line there, but anyways. So we have, that is the payload. Then we have to put the headers. So headers is equal to content type, then application, x www form URL encoded. And we did this because we learned from FFUF, if we don't have this header, it's always going to say OK. And then the data is going to be message is equal to payload. And the reason why I kind of just didn't do the payload with data, like there's no reason I couldn't have done like data equals here and been done with it. It's mainly just like I like having payload and its separate thing in case I want to do any type of editing or massaging the data. So we have that. And then we can actually make a request. So R is equal to request.post http 10.10.10.195/submit message. Data is equal to data. Headers is equal to headers. And the one thing I notice I'm missing is after guess, we need a %. This is the wildcard. Okay. That looks good. And we can say if OK in r.text, close the quote, and it's .text. Then return 0, else return 1. We could go return true, return false if that's easier to read. So now we can say check, or if check result. We could probably just say print. Print check result. We'll say F and A. See what happens here. Python 3 get PW. Of course, I use Python 2 syntax for my print. I don't know what I was thinking there. It's been forever since I even touched Python 2. We get true both times. So we definitely screwed something up. So let's see. We can print payload. I'm guessing it's probably within the headers, if I had to guess. So case when, select secret. This looks good. So I'm guessing I have screwed this up and put a typo somewhere, like right there. And we have it fixed. So now we have a way to brute force a single character at least. So let's make the function now. We'll call it brute. And the very first thing we're going to do is set PW equal to nothing. I always like to set PW to pass, but that's an actual variable or a function, so we can't. Could be password, but that's a pain to type every time, so that's why I do PW. The char set, I'm going to assume this is a hash, so we're only going to go up to F and then all the characters. So if we do for char in char set, print char, and we had called brute, Python 3 is going to loop through that character set, which is awesome. So we can do for, we can say if check result char print char break. Let's see. I don't know why that did not print A, B, C, D, E, F. That's weird. For char and char set, check result. Let's do else. Oh, we're not running it. I was like, that's also going very fast. We killed the brute function. So we get the very first character. I'm going to do something for style. This is all just personal preference, but import the sys module. And instead of printing, I'm going to do sys standard out dot write f \r pw I. Let's see, we can also do that. And then sys stdout dot flush to flush out. So now all that did, if I typed it correctly, let's see, sys, oh, I don't know what I did. There we go. I is not defined. Of course it's not. We called it char. See, you may not be able to see it now because it's going fast, but it should loop through and just print everything it's doing. So you'll see when it actually works. Let's see. Yeah. Maybe we do this up here. There we go. But let's just wait until we get rid of the flush. Is it going to print all the characters? No. We'll come back to that. The next thing we have to do is go through and go to the next character. So I'm going to do something really messy, and I'm going to infinite loop this. And on this checked result, we're going to increment password or add to the password variable. So pw equals char. So every time it gets a valid hit, it's going to add the next one, and I think we need to actually do that flush. So let's do sys stdout flush, and oh wait, that was not that. Char, it's actually going to be pw plus char. So it was just going after and trying to brute force the very first character of the password every time, because we weren't using this pw variable. So now we get, yeah, we should do flush because it's messing up how it's printing. So you can see how that looked, and then if you do sys standard out dot flush after each one, it's just going to clean up the output. Let's get rid of this first print. I have no clue. Oh. Because we do the password increment there. So I don't think we have to actually flush. Yeah. There we go. So we can see it now actually getting the hash. I was trying to get it so it would actually show each attempt it's doing, but I did not do that well. Let's see. I wonder if I do up here before the check, we can do sys standard out write password plus char. like that. There we go. So now we have it actually writing as it goes. So we just wait for this to finish, and we will have the hash. So I'm going to speed up the video until this starts looping, and it's important to know that this script won't terminate itself. It's up to us to terminate it. So you'll see that in just a second. So here we go. It's already cracked everything, and we see this is just continually looping. So I'm going to Control-C, and we're going to copy that. Oh, I think it. I do not think it like that. Let's see. Because I don't think that's long enough. Echo-N WC-C 32. Is that 32 characters? I'm just going to run it to make sure. And then, yeah. So that last A is actually not something. So it's this. Copy. There we go. We got the hash. I don't know why it wasn't letting me copy it before, but we finally got it. Echo-N WC-C 31. So I think there's probably something else to this hash that we had screwed up. So I'm going to go back here and let's get the password. I'm going to say like and put the hash, and we get not authorized. Put a percent at the end, we get OK. So we did miss something, and it's not an A. So our script did something wrong. I don't know what it did yet, but we're going to find out what it was missing and then try to fix it. 0, 1, 2, 3, 4. Really? What am I missing? Oh, it's FD. FD percent. So I'm just going to send it to intruder because this is the more optimal way to do it. And we will clear that. Put one here. Go to payloads. And then do we have like hex here? A to Z. 3-letter words. H. Oh, I did too many. Oh well. There we go. So now we have that. We can start this attack. And probably based upon the length, I would think. Maybe not. I swear we're missing one character. Because 31 wouldn't make sense. See, is this response always not authorized? It is. A, B, C, D, E, F. And we send that to repeater. So maybe it is only 31 characters. Oh. Wait a second. 1. So we're hitting a character thing. Message too long. So that's why it's not displaying the very last character. I don't think we need a space between that then. So we can do 2 parentheses there. There we go. So that's it. We actually hit 140 characters exactly at 31. So we had to shorten up our payload by getting rid of that white space. That is annoying. Let's see. I hope that's the whole hash. We may have to do it we may have to break it up into substrings because maybe we can't put this whole hash here. So let's get rid of that space. Start attack. And it's still not authorized for everything. What does a request look like? FD. and F%. So FD. Let's see. So the issue is this is probably going to be longer than 32 characters. My assumption with doing all these intruder modules has been it's going to be a MD5 sum. So when I was doing the intruder, my request doesn't have a percent at the end. So it's not like this because it goes into extra characters. So we probably have to do a substring because we're hitting the maximum number of characters. So let's see. We know it's F1. So I'm just going to be vnote F1. And we're going to do a substring. So let's try, let's see. I think substring goes on the outer. So substring select 0, 1, like that. And then the first character, which I think is 1, 1. I think this is right. Is like F. Select syntax. So we definitely screwed that up. Let's see. In case when substring select secret. See if we get rid of this. Like F, okay. What if I can do a substring here? Substring secret. And then 1, 1. Okay. We do 2, 1, not authorized. So this is where we can do it. The third character F. Second character should be 1. So 1 is F. 2 should be A, I think. 1. There we go. So this is the new query we want. So let's copy this. And let's see. I'm going to make a backup of our get password script because we're making tons of changes. So payload is equal to F, like that. Okay. And let's see. Guess this will be position. And this will be, where's that F? This is guess still. There we go. So now we have to keep track of the position. So let's see. POS is equal to 0 for char and char set. We're going to do POS plus equals 1. And then check result. We're only going to give it the char. We'll do position and character. There's no way this works first try, but we'll check it out. Oh, 0. What? That's definitely not what it should be. 0C, 0, 2. And then it ends. Let's see. Password, position, character. So let's print POS, print char. And I think the easiest thing would be do is send this to Burp Suite. Because I have no idea why it's behaving like this. Let's see. Let's comment those out. And before I send it to burp, I just want to print the payload to see what it looks like. Oh. No, that's not it. Oh, shoot. We're incrementing the position every time we do a character. So that's a mistake. The increment should only be when we detect a valid hit. So POS plus equals 1. There we go. So if you looked, every single request was incrementing the position. Shouldn't do that. It should be whenever it gets a hit. So as soon as it hits F, we should have got the position to increment. Let's see. I'm going to go back and look at this. I don't know why it keeps putting in A at the end. Let's see. A, B, C, D, E, F. So this is where we should have incremented. So, and case, substring, oh, we begin at 1. Substring begins at 1. There we go. So as soon as we hit the F, it should increment. There we go. So, finally have it, I think. Let's see. Print. There we go. So it looks like it's working now. And this way, our payload doesn't actually get increased when we're guessing. So we should never hit this 140 character limit. So I'm going to speed up the video and we're going to wait till the hash is complete. So it looks like it is done, and we have a long hash right here. So let's copy this, and we will vhash, paste it in, wc-c hash, 65 characters, which is probably going to be 64 in a line break, echo-n, wc-c. Yep, 64. So that is the hash, what this is. We can't really use this. At this point, I tried to go into Hashcat and crack this hash, but it's not crackable. So I'm going to save the time of that, probably save 5-10 minutes off the video, and we'll just pretend we cracked it with Hashcat and it didn't work. At this point, it's definitely when you need to find this source.zip on the website. So we can download it and start poking at the source. So let's move source.zip into a directory and unzip it. And we go into the source. I'm just going to run Codium, which is Visual Studio Code. And we can poke around at the source to see what the vulnerability here is. So the very first thing we look at is the submit. We can see on/submit, it's a method post. Submit message, submit is a get. Submit message is post. Here's where it's saying if characters is greater than 140. And we also have the injection, query db, insert into messages, values, this, and message. And message is gathered right here. So request form get message. And we're checking the length here. Check those bad words in the string. So we could look at what bad words is. We have to look at that function. But it's not doing anything other than that. And then passing it straight to this insert. So that's where the vulnerability is. So from utils, import this so we can look at it. And we just can't use ran, system, exec, or date in our injection, which we didn't do anyways. So yeah, that is the injection piece. So the next thing in applications is generally look at how like login sessions are handled. So it's probably going to be, what's LWT stand for? I think this is what we want. I can't remember what it stands for off the top of my head. It is using SHA-256. So it maybe like lesser JWT, because if you look at the actual cookie, we made a point of getting rid of the cookie on every request. So let's go to one of our very first requests to this app here. Do we have our cookie? So if we look at how this cookie works, let's see. The cookie. This is what it is. We can get rid of auth because that's just the name of it. JWT tokens are normally 3 base64 blobs. This is just 2. We got a blob right here and a blob right here. So let's take a look at what that very first blob is. So we can do cat cookie awk-f period print 1 and then base64-d, and we can see the cookie's username, guest, secret, like this. So let's look at the second field, what that is. And it looks like it's just a blob. So looks like it's just a hash. And this is probably going to be a, let's see, -c, we'll just do 100. And wc-c this. 64 characters. So this is just a SHA hash. So if it was JWT, you'd have a blob before the data that just explains it's a JWT, like type JWT, hashing algorithm, whatever. So we're missing that. So this is a homegrown type crypto thing. And we can see how it's being signed. So it's returned SHA-256 secret plus message. And the secret, every time the application starts up, it's doing a os.urandom, so it's just grabbing random bytes. Urandom is the secure way to do it. And going from 8 to 15 in length. So this is a huge key space to brute force, so we probably can't just try cracking it because theoretically the password would be 8 to 15. Yep, 8 to 15 bytes of data, and then this. So can't really crack that. We can look at how, but can't really crack it. However, it is vulnerable to a hash length extension, because in hash length extension attacks, it's complete magic how it works to me. I fully don't understand it. But if you have this secret, you can generate new SHA sums if you just start truncating and getting rid of this piece. So because the secret is before the message, we can do this attack. If the secret was after the message, we couldn't start removing the message because we can't really control the end. We can only control the beginning is a good way to think about it, or how I think about it. So if you Googled around for like hash length extension attacks, you'll probably get a better explanation than me, because I still don't know how they work. You kind of just continue doing the hashing algorithm if you remove this piece. So instead of blubbering, let's just do it. I'm going to use a tool called HashPumpy, or a Python module called it. And, well, HashPump is the C program, but HashPumpy is the Python program, I think. So if you do pip install HashPumpy, I think, it should install. Maybe pip 3. Let's do Python 3. So it's all already installed for me. So let's v hash extend.py. And what we're going to want to do is pretty much the same modules. So we'll import request, import HashPumpy, and we'll see if we need anything else. So the first thing we need is the cookie. So we can say hash is equal to, and it's going to be a byte object. So let's do, let's see. Do I have an invert? Let's go to proxy. There's whatever I did my awk thing, but I don't know what that was. So we'll just grab it like this. So we can do echo-n base64-d. I'm going to grab this. So copy, paste, and then the next thing we need, or that's not the hash, this is the cookie. We'll say guest cookie, and then guest hash is equal to b, and then the other piece of this. So we can grab this. This is what it's used to sign the cookie. So echo-n base64-d xxd-p-c100. Put this in here. Okay. And we're going to want to create an admin hash or admin cookie. And it's going to extend the cookie. So I'm putting a semicolon at the beginning, just because if we look at how this parses, it splits by semicolon. So that's why I did that here. Admin, and then the secret is going to be the hash. Let's see. This. So if we brute forced the guest account, we'd get this hash. The hash is the password hash. So if we go up one, oh, whoops. We had it here. V get PW. If we change this to limit 11 instead of 01, it's going to get the second user. And you'll see it gets 84 probably. 8, 4, 9, whatever. So that's now getting the that hash. So what we need is a test cookie module. So we can do def test cookie and give it the cookie. And then cookies is equal to auth cookie. And then R is equal to request.get HTTP 10.10.10.195/admin. If we look at here, we have this route admin. At the very top, it says if is not admin request, abort 403. So there is no, remember in the very beginning of the video, we talked about something on submit message. There's nothing here that is doing a permission check. So that's why we could hit it. But we want to get to /admin. And then cookies is equal to cookies. I think that's all we have to do. And if r.status code does not equal 403, because if we try to make a request to admin, it's going to give us a 403 error. So let's see, do I have anything I don't care about? We can just go to proxy on this get submit and change it to get admin, and we get 403 forbidden. So if that, return true, else return false. So there's test cookie. And now we have to do the hash pump attack. So we can say for I in range 8 and 15. And this is the bytes that secret could be. So if we went back to LWT, secret is somewhere between 8 and 15 bytes. So that's why we're doing this. And we can say, what's the next thing? We can get rid of that, give ourselves a little more space. So let's do HashPumpy dot hash pump. Did I do it correct? hashpumpy.hashpump. I should probably be doing this in Visual Studio where it gives me everything. It wants the guest hash first, this piece. Then it wants the guest session, or guest cookie. So we give it these two pieces, and then it wants us to give it the pieces we want to forge. So we'll do admin cookie, and then I. And I is going to be, again, 8, 9, 15. That's going to be the length of the secret we're trying to extend away from. So let's see, does this even work? Cookie, line 9. Let's see, cookies. We need to do auth cookie like that. Else, forgot a quote, colon. So let's see. Does not look like it worked. Let's see, print. We print this out, what happens? Okay, so it returns two things. It returns the signing key, or the new SHA hash, and then the new cookie that it extended. So we can say new sign, new cookie is equal to that. And then we just have to encode them. So we can say import base64, or wait, from B64 import base64 encode, I think is it. We'll see. Again, probably should be doing it in Visual Studio or something, or IDE. It's actually not base64 encode, it's B64 encode. Muscle memory comes in super handy. So B64 encode, new sign, and we'll do B64 cookie is equal to B64 encode, new cookie. So let's print these to make sure they're good. B64 cookie. From base64. I kind of like got those two things reversed. Bytes like object is required, not string. So let's see. Maybe it's dot encode here. Did HashPumpy give us strings? Where is the error? Deprecated line 19, B64 sign. I put the encode at the wrong spot. So right here. Bytes like object has no attribute in code. What? One of those was probably encoded. There we go. So this was a string, this was a byte object already. So we got it working. So now we just have two base64 blobs. So now we can just reassemble the cookie. So we can say cookie is equal to b64 underscore cookie plus, and we'll do plus b64 sign, and we'll print cookie, and we're almost done if we did this correctly. So now we got a few cookies. Hopefully these aren't all the same. Yeah, they look slightly different. So now let's test it. If test cookie, print cookie. First byte must be a tuple. Oh, come on. Maybe dot decode. And we didn't get anything. So we did something incorrectly. So everything returned with an error. I'm going to print the cookie here. And we're going to see what the cookie looks like. And it looks fine. Actually, the signature looks a bit big. What's the signature before? Where is Burp Suite? Go here. The signature is like half the length. Echo-n, paste this. WC-C, that's 44. And this signature, Echo-n, WC-C, 88. So what's happening is how we're doing the hashing. So you remember when we went with the valid signature and did Echo-n base64-D and we just got a bunch of junk? And that's when we did like XXD to turn it into hex. Well, in Python, we base 64 to string, not each hex byte. So if we do Echo-n base 64-D, we just get characters. This should be in bytes. So we shouldn't be able to display this. That's what mistake I just made. So we can change this where it's B64 sign. We don't need that encode there. We can do a bytes dot from hex to convert this into hex. And let's see, Python 3 hash extend. Probably get rid of printing every cookie. And let's pray we only get one cookie. There we go. We just got one right here. So let's try going back to a burp suite repeater. Go here. We don't have permission. We can do cookies auth is equal to that. Don't have permission, but maybe I did the cookie wrong. Yeah, it's cookie, not cookies in a header. So now we can see the admin panel. So we can go up to Firefox and go back to our page and try to hit /admin, and we get the forbidden, but we can go tools, web developer. I'm just going to do web console because I know storage is right there. And we can replace the cookie with our cookie. Make sure I replace the whole thing. Okay, with our cookie, refresh, and we get welcome admin. So we are now an admin on this application. We can go back into our Codium, and we have two functions now. We have admin log view and admin log dir. The post modules. So let's go back here. I'm going to do view dir. I'm going to change these to post. So admin view dir, and change this to post admin. Wait, did I do it backwards? No, dir's there. So admin log view. Log view. And this is log dir. And it's saying the argument here is log dir. This is log file. So we can do log dir is equal to /, and we can see all the files in /. We can do here, which is log file, etc passwd. Was it log file? Wait, what? admin log view, admin log view, log file. Maybe we have to do dot dot slashes. There we go. So it's a directory traversal too. So looking at this, there is something unique. In the very first hint, there was SNMP on the box, this Debian-SNMP. And let's go back over to our pane. We can see nmap reported SNMP was open. But the first hint of SNMP is obviously Debian-SNMP being here. And the other thing I always like doing with directory traversals is going into /proc. So proc sketch debug is a file that has a bunch of processes running on the box. And we can probably find SNMP somewhere. So I'm just going to search for service. So that's PwnTools. Let's go to the next one. Nginx, app. We have a bunch here. A note server. So this is a application. We don't know what it is. We may be able to get the configuration file for that and see exactly what that is. And we got app service. So these two services we don't know. There's probably an SNMP one, but I'm going to make notes real quick. App.service, and the other one was something with a note. Note server.service. So we got two things there. SNMPD. We have processes here running SNMP. If we go up, is there SNMP service? I think it may be right here. Yep, SNMPD service. So again, that sketch debug file is big. And you also have proc net TCP. This is going to show every port that's listening. So this is in hex. So all zeros, this is going to be any host. 50 in hex. If we go over to Python, Python 3 print 0x50 is 80. 35, this is localhost only. So 127 is at 7F 0001. Maybe I'm wrong there. I think that's localhost. 35, what is that? Is that 53? Yeah, 53. So localhost 53 for DNS. 16, this is going to be 22. That's SSH. Yeah, I don't know what this one is. This is 127.0.0.1. So 127.0.0.1. This is 127.0.0.35. So which is 53. So on 127.0.0.53, DNS is listening. Weird thing. I don't know. 127.0.0.1, 1389. Don't know what this is. Port 5001. So we got something listening on port 5001. And then 50, we already said this was HTTP. If you go over to UDP, you have a few things listening on UDP. So 127.0.0.1 on DNS, or 100.53 on port 53. Then you got this A1. A1 is 161. And then I don't know what DDF6 is. 56,822. So that's how you enumerate kind of what's listing on the box. Port 5001 is definitely interesting. If we go back to the notes, node server.service, maybe that's 5001, potentially. So let's enumerate more. Let's see what's in our current directory. So this logdir period, and we have a few files, app.ini, database.db, admin.py, app.sock. We could try like app.ini to get the file. So we can try app.ini, maybe /. We have to get into the directory. I think. Is logdir, let's see. So it's doing admin list log. So let's see if these directories are different in utils. Admin list log is going into logs. Let's just try /app.ini. There we go. So that's the configuration. I just got this because I didn't know if there was a password or something in the configuration. So right here, we kind of got to enumerate exactly what is on this box. So let's try going into the home directory. Maybe there's like an SSH key we can get. So let's go to /home or logdir, a bunch of /slashes. There's a home user, a few files in here. So user.txt, there is this noteserver.c. So we may want to grab this. So let's go to view, and we can do noteserver.c, and looks like there's a program. So I'm going to save this. Let's go back. Oh, we can turn, I guess, pretty off. I was trying to make it pretty. vnoteserver.c, paste it, and we'll keep going. We may want to see if we can find like an SSH key. So what I'm going to try to do is SSH keys can only be readable by their current user. So let's see what user we are. Proc self environ. Proc self cmd line. Does this work? Internal server error. Environ. Oh, I'm on directory. Copy this, go over to view, paste, and we are, let's see what user we are. Lang, bin, we are web. User equals web. So we can go back to etc passwd to see where our home directory is. It looks like it's just in /. So we can check if there is a /.ssh. And it doesn't look like there is. Let's just make sure there's no directory. So since there's no SSH directory, we can't get in. The only thing that's really sticking out is the SNMP stuff. So let's try etc SNMP, that directory, snmpd. Let's do etc. Oh, I always forget this directory traversal. SNMP, and we have a snmp.conf and snmpd.conf. Let's take a look at snmpd.conf. So, do I have it there? Let's do etc snmp, and we have some information. And there is a read-write community of superprivcom90. And whenever you have read-write on SNMP, you can do some pretty bad things. For instance, on Cisco devices, you can edit where the TFTP backup is, and then tell the device to perform a backup. So you edit the TFTP backup to be your IP address, tell the device to back up, and it sends you its backup file. In this box, though, SNMP read-write can actually get you a shell. Let's see if we can find the blog post on this real quick. SNMP read-write Debian-SNMP exploit. Is it here? Maybe this post. I'm not going to go too in-depth in all the like SNMP set command and everything, because it is super specific on like doing spaces and things like that. Instead, we're just going to try snmp-shell. So when you have a snmp read-write string, you can always just try snmp-shell to see if it actually gets code execution. I know it's not normally like the IPsec way to not explain, but this box is a beast, especially for a hard machine. So we can install this. So it wants us to install these things. There we go. And then we do a git clone and go in and then do a pip install. So it's installing all the MIBs. And if we did a snmp walk-v2c-c public, I think 10.10.10.195. Let's see, we'd probably see some stuff that indicates it is vulnerable. Maybe not. So let's see, did that command finish? Okay, we have now installed it. So we can do the next thing, which is a git clone. Go into snmp-shell. And we will install. So it's installing all the requirements for this. And we can try how we do it. So it says snmp-shell, like this. So RL wrap. I'm going to specify Python 3 10.10.10.195-c and paste the community string, which is probably in our brip suite, and see if this gets a shell. If we do ID, we have a shell. So pwd cd home. So we can cat etc passwd, and we can go into verlib snmp. We can't get a shell here, but we can write a .sh directory. So one already exists. And let's see, we can add a key to this. So SSH-keygen-f intense cat intense.pub. Let's copy this. And let's see, echo-n. Probably shouldn't do like VI or nano or anything on this type of shell because it's not a reverse shell. Cat authorized, did I put it in? Probably should have done 2 dashes. Echo-n authorized keys. Let's see, LSLA auth. Okay, we can write into it. Maybe it doesn't like the directors we are doing. Touch T, cat T, echo this. So this is, I guess, too big. We can only go up to 255 characters. And that is probably going to be a lot of characters. So we can do echo-n wc-c, 544 characters. So way too big. There's probably a different algorithm we can use with SSH Keygen. So let's try ECDSA. Do we have to specify anything? Block size. Let's do like that. We probably have to do -f intense. Overwrite the key. And let's see, cat intense.pub. That is much shorter. So let's do echo-n wc-c 140. So this will probably fit in 255 characters. Let's try this. We could have broken it up in multiple chunks, but I want to see if this works. Authorize keys. Did not fit. Okay, so let's try this. Authorized keys. we need echo -n cat authorized keys. So let's see. Let's try echo -n paste to T. So we wrote that, I think. Yeah, okay. It's just weird how it kept displaying. I guess it's just this shell. So we can do echo -n and then paste a little more. To T, echo -n, paste yet a little more. Let's remember, let's go to the note server, exit. Let's see, what's HAY. Okay, grab here. Paste a little more to T, echo -n. And there's a firewall on this box that I'm just didn't enumerate because I know, because I did this box a while ago. So that's why we didn't go and just try a curl. Trying to speed up the video a little bit for these super hard machines of not trying things that are super basic. So if we cat T, I think that's it. So we can cat T to authorize keys and try to SSH. So chmod 600, intense, sh-i intense, and Debian-SNMP at 10.10.10.195. And we get permission denied public key. So that did not work. I'm going to echo a blank line to authorized keys. We can cat authorized keys and see what this is. Maybe this algorithm just, it did not like the algorithm, and that would be a shame. V intense.pub, paste, and we're definitely missing a lot. NTYAA, missing a whole chunk like right here. Cat intense.pub. So let's try this one last time. Grab this. Echo -n to T. Echo -n. To T. Echo -n. To T. And you can see why I didn't want to manually do like SNMP set commands now and just opted to use the shell. Because this is not an easy exploit to pull off. Okay, cat T to authorize keys, echo to blank line, so we can just do that and see if we can SSH. There we go. We don't have any denied, but a connection immediately closes. So we can't really execute commands this way, but we can do SSH tunneling. So remember port 5001? We can do a tunnel to that. So I do -n to tell it not to execute any commands. And we'll do -L 5001 localhost 5001. And here we can do netcat lvnp, or netcat 127.0.0.1 5001, and we connect to the port, I think. Yeah, we're connected, but nothing's really happening. So at this point, I guess we just have to figure out exactly what this is. We found the source in home user, and there is, I guess, the binary right there, and then noteserver.c. So we could probably download that binary. So if we go back to view, home, note server, home user, .c, can we, okay. So we could potentially base64 it, unless that's a directory. Note server, nope, that's a file. So cp note server, or we'll do base64 note server 2, and we'll write it to temp note.b64. Temp note.b64, and we can save the file. So copy, go to a new thing, v note server, probably should call it .b64, base64-d, and chmod plus x, note server, and now we actually have the server. It says the port is already in use because we have this SSH terminal up listing on 5001. So I'm going to kill it, and we're just going to run it locally. And when we connect, we're not getting anything to it. So at this point, we probably have to enumerate this application. Thankfully, we have the source code, so we don't really have to do too much reversing. So let's just look at it. It was note server.c, and let's find where main is. So we have main, and oh, right at the top, it did tell us how it was compiled. So that's handy. So let's look at main, and we have some socket stuff. Let's see. This is where it listens on port 5001, and then it listens only on 127.0.0.1. And creates a child process by forking, and that fork looks like it is handle client. So let's take a look at what handle client is. And the very first thing we have is it defining note with a buffer size of 1024. So there's not too much to this application. If there's a Stack Overflow, I'm guessing that's where it is, because that's just screaming buffer size, literally all caps and everything. So we can see all the other variables that get pushed on this, and then look at it. So looks like we got some type of case statement. So let's figure out what this is. Case 1. So if 1 is sent to the socket probably, then let's see. I guess if it doesn't conform to the message, then exit. Make sure users are writing less than the buffer. And here we go, we write the note. So it breaks. So we should be able to write to that socket, but I don't see it printing anything. So let's keep on going. We have copy part of the note to the end of the note. So this piece can, I guess, as it says, copy the note. So copy a piece of the note over top. We can probably explain that more in a minute. And then this last one is printing data. So this explains why we couldn't get any data, because we didn't send it in the correct format. So in order to send it in the correct format, we have to like do echo-en. The E is going to let us send characters via like hex. So if I just did echo-n\x00, it says that. But this will actually process, but there we go. Has to be in quotes. So there's the difference. So we can send 0, 1, And then the next thing it wanted was the buffer size. So the size of the message we're going to send. So I'm going to send 04. I'm going to say test. And then we're going to call it by sending 3, which sends us into the case statement 3. And we'll do netcat localhost 5001. And that did not work. Let's see. 01, 04, test, 03. Let's restart this. Oh, I'm not doing the -e. There we go. So there we go. We have the server sending test back to us. So we can kind of interact with the server. Let's create a Python script to be able to send messages to each of these pieces before we look any further. And I'm going to use PwnTools. So I'm just getting here so you can see the C code. And then we'll call this exploit.py. And the very first thing we'll do is from pwn import star. And then the context binary will be note server. And this is just setting up GDB things, or not GDB, PwnTools. E is equal to context.binary. And libc we're going to do later. So P is equal to, that's process remote 127.0.0.1 5001. And this is just int. There we go. So we can write to the socket. So write, and we'll send it data. And we'll do p.send \x01. Then p.send. We got to do the padding. So I'll do padding 8. This is a PwnTools thing. Len data. Close that out. p.send the actual data. And we could have put this all on one line, but I find it easier just to break it up. It doesn't really matter. So this is like length of data, enter write, and then this will be the data. So the next function will be copy and offset and size. p.send \x02. p.send, where is the offset? Let's see. Is offset defined anywhere? It's a 16. So if you wondered why I did P8, it's just uint8, uint16 here. So just making sure our Python thing sends our C program in the exact format it wants it. So instead of P8, we'll do P16, and then offset. And I forgot a single quote here. Syntax highlighting helps so much. P.send, and now we can send the size, and the copy size is uint8, so P8 size. And that's it for copy. And then there was read, and read was just we sent it 3. There we go. So now we have that. We can start our exploit. So we may be getting ahead of ourselves a little bit, but the actual buffer overflow happens with the buffer size. So if we look at case 1, we have a check here that prevents us from writing over the buffer. So every time we write a note, it's just adding it and adding it. So if I did this, and we do \x01, we'll do 5, I guess, and we'll say test dash ip with an exclamation point, maybe. I think that's 5 characters. And oh shoot, \x05 or 0105 test, or that's 4, 5. So we sent it one message, and then we sent it another message, and it gets displayed. Yeah, so got displayed here. So this is showing that it keeps the buffer indefinitely or until the session dies, and it will stop being written if it ever goes higher than 1024 because of this check. So let's look at what they're doing to protect the buffer on case 2. Right here, we have, let's see, sanity check, right here. Prevent user write over buffer notes. And it's only checking the index. So it's not going to check what you copy. So if we're at 1024 and then we copy more, we just increase this buffer. So what this attack is doing is we're saying we're filling the buffer up with 1024 characters, and then we're using this copy function to tell the program it's actually longer than 1024. So that way when it reads 1024 and then some extra. So that is the theory of the exploit that we're going to try to show. So let's do log.info stage 1 defeat ASLR. So we're going to write A times, we have to go to 1024, and because the size is just a single byte right here, right here, we're limited to 0xFF, which is 255, since we only have 1 byte to work with. So I'm going to send it in we'll do 4 things of 200. That's going to get us to 800. Then we're going to send 224, and that'll get us to 1024. So 200, 400, 600, 800, 1024. So we just filled up the buffer. So now let us copy at 1024, and we'll take the maximum amount, which is 255. So the offset is, we just told it to go at the very end of the buffer and then go the next 255 bytes. And this copy thing may make more sense in a minute. So we're going to read, then we can do p.receive 1024, and don't know too much else. So let's just run this program after we compile. So I'm going to head this note server.c thing real quick, and it gave us compile instructions. So gcc, wall, pi, stack, whatever. I'm going to do this, and I'm going to add 1 flag to it. So we're going to add -ggdb, which is going to allow us to have use a source code when we're debugging. So we just created a new program. So we have note underscore server and note server. I'm just going to move note underscore server to be note local, and we'll move note server to be note remote. And if I do gdb on note local list, we have source code. So that becomes super handy. Let's go into the Python program again, and this is going to be note, what I call it? Local. Okay. We can exit or quit, and we can do LDD, note local, and that's going to tell us where LibC is. So we'll put that here. So we can do v exploit and grab libc, and this can be is equal to that. Is that how I did it? No, we needed elf like that. There we go. It's not important yet, but I just like putting that there because I'm known to forget to set those type of environment variables in PwnTools. So now we should be able to Python 3 exploit.py psef grep note. Let's make sure our process is dead, and let's run it. GDB note local break main run set follow fork mode to child because we know it forks. I'm going to do list 0, so we're just going to go through the source code, and right where the write is, that's why I want to break. So right here, this is what I want to break on. So B82, and then we can continue. And when we run this exploit, we do see stack canary found, dep, whatever. But we're here. So we can do something called telescope. And we're going to say on the note variable plus 1024. If we don't do, if we do that, it's just going to go to a bunch of A's. If we go to 1016, which is 8 characters before 1024, you can see the very first address is going to be A's, and then it goes to the actual stack. So this is the data that we're reading right now. So we set our offset to 1024 and then read the next 255. So this is what is going to get sent to a Python program. I don't know what this is. This is going to be a stack canary. We could have debugged and stepped through this more, but just before RBP, if there's a stack canary, that's what this is going to be. We got RBP. This is going to be the return address, and this is going to be location of base. So I'm going to kill my program. And I know we're doing this buffer overflow super fast. This video is long. I don't know what else to say. Let's do p.receive 8, and this is junk. Then we got canary is equal to the next 8, right? And then after the canary, what did we say it was? RBP. So we got RBP is equal to p.receive 8. Then we have, after RBP, this is going to be the return address. And then we got the base address. So we have a bunch of information right here. We can do a log right here, log.success, and this will be canary, and that is U64. What if we do, let's see, we should do U64 unpack 64-bit. There we go. U64, do that on all these. U64. Let's fix this real quick. There we go. So now I have syntax highlighting. It always irks me when I break syntax highlighting. U64. There. So we should now be able to print canary like that. Let's see what happens when we run this. Probably going to be some type of error. Let's see. Junk. Remote object has no attribute rev. Receive. There we go. And we have the canary here. We can print it out in hex format to make it a bit easier. And all we do is put hex before it. So canary, it's going to be hex like that. And now when we run this, the canary is printed well. We have to get the base address, and we can also do that in this telescope thing, I believe. So go back here. This is the address we want. So I'm just going to do x\x, copy this address, and we'll subtract it from the base. And can't access memory. Oh, because we terminated it, we can't access it again. But it gave us the number we want, 1674. So that's going to be the difference. And this is going to change on different binaries. So when we go back to do it remote, we have to remember to change this. I say that, but I know I'm not going to do it. So we can do e.address is equal to ret minus 0x1674. And that e is right here where I did context binary. So this should be the location of where the program is. So we can begin stage 2 now. And what that is, I mean, ASLR is going to change where it loads every time. So let's say this is where our program is. And we know every time, doesn't matter where it is, as soon as we find O, we know we go back 3 and we hit P. So even if the stack like loaded the program back here, and we get this address of O, which is what we did, we go back, we find P, and now we can find all the other ones. So again, that's all we did with this piece. So stage 2, this is where it's going to get tricky. We're going to have to do a ROP chain. So I'm going to go back up here and we're going to do def exploit. And because of the whole copy thing, that's why I'm doing it this way. This was copy is going to make sense. So exploit, and we're going to send it the ROP and canary. We can do variables like this because that's the order they will go. So payload is going to equal 8 pieces of junk. And the reason why we're doing 8 is because we did 1024. So let's go back to this telescope. Is it going to let me? It is. Sweet. So we are right here, and we want to write this data. So I'm writing junk on this one. Then we're going to put the canary. Then we're going to write junk here. Then we're going to write the address of where a ROP chain is here. So that's the first junk. So payload plus equals. Now P64, we're going to pack this back up. Canary. Then we're going to, if I do plus equals, that would help. P64 RBP. We don't have to put the correct base pointer, but we could have done all A's. But it always helps to do things as legit as possible. P64, this is going to be actually the ROP. So this is bytes ROP. So a ROP chain there. And then we're going to put some junk in. And that's going to get us back up to the 200 characters, just so we can save on math later. Because we always have to write 1024 to the chain. So we're going to do A times the length, 200 minus the length of a ROP chain, or a payload. So there's that. I think that's correct. Hopefully it is. And now we can write payload plus junk. And hopefully this is equal to 200. And then we can just write the A times 200 a few times. So 200, 400, 600, 800. And this is going to be, come on, Vim. Oh my God. There we go. That's going to be 1024. So this is 200 and length. So 2, 4, 6, 8, 10, 24. Awesome. The next thing we do is we have to copy. So we copy 0 and then length of payload. And what that just did is instead of copying at 1024, which was the very end of our payload to copy the next bytes afterwards, we're just going to copy at the very beginning. And where the very beginning is, that's where a ROP chain is. So we just put a ROP chain plus enough A's to get to 1024. And now we're using this copy command to go back to the original payload, copy that piece of ROP chain, and put it on the stack. So that's what that copy does. And after copy, we can read. And then let's just for handy sakes, let's go up to exactly where we are. So after it runs this exploit, we're going to receive 1024 because that's the A's. Then we're going to skip ahead of all our ROP chain. And that should be kind of where the output of the stuff is, if we did everything correct. So stage 2, we have to reconnect. And the canary and everything is going to stay the same until the server gets reverted or rebooted. That stuff happens as soon as it boots. So in PwnTools, I'm now creating ROP chains out of the binary, which is note server. And we're going to create a ROP chain, linking the procedural linkage table of the write. So this is going to write it back to us. The socket of where we are, let's see, RDI is 4, and we're inside of a fork. So most likely that's the file descriptor. So writing to file descriptor 4, and then on the global offset table, we're going to link read. And read is a function within libc. So if we link the address to where read is in libc, we can do exactly what we did with main and find out where the beginning of libc is. Once we know where the beginning of libc is, we can find all the functions no problem. So that's what that is doing here. And we do exploit and then canary ROP. And if all goes well, read is going to be the next 8 bytes. And then we can do libc.address is equal to read leak minus libc.sim read. And then we can go over to stage 3, execute code. This is going to be find libc. So this, defeat ASLR, find libc, and then stage 3, stage 2, so this is stage 3, parent all the things, and rename this to 2, and this is going to be pretty easy. Since we already did the ROP chain once, all we have to do is create a different ROP chain. So this time we can do ROP is equal to ROP libc. And then we do bin.sh is equal to, find where lib.sh is in libc. It's just a string. So that's how you find that. And then we do ROP dupe2 40 1 2. So what this is doing is setting standard out in an error message to file descriptor 4. And then we just have to call execve, which is rop.execv, and we'll do bin.sh 0. And exploit canary ROP and drop to interactive. So if we did everything correct, which I don't think we did, we should get a shell. Oh, we did. So we have a shell here. It's not going to get us a shell on the remote server because we have a few things we have to take. We have to get libc, and we also have to find the address of main. So let's just quit this and be happy it worked. So kill 184854. Oh man, it's a high PID. So where's SNMP shell? Here it is. Is this where note server is? It is. So note server. And let's just copy libc right here. So we can do base64 this to libc.b64 or temp libc.b64. So we copied that and we have to download it. So we can go back over to Burp Suite and download it. This is going to be much bigger than the note. So we probably want to save this. So copy to file, and we'll call this libc.b64. And we can go back to this pane, base64-d, libc.b64 to libc, v libc b64. Just get rid of the HTTP header. There we go. That is an ELF. That is good. So here, just going to comment this out, and I'm just going to put /libc. So now it's going to pull from that. And then we also have to do note remote. And we have to get the address of where we are. So let's do /note remote. And unfortunately, we're not going to be able to do the trick of just setting a line break on the right immediately, because actually we may be able to. Do we have disas handle client? Sweet, we can. It's not stripped. So we need to set the break right here. So let's do b star this. We'll do break on main as well. We can run the program. It doesn't like something. I'm just going to break main, run the program, then we'll do disas. Do we still have it here? What was the thing? Handle client. And we can break. I don't even know why I ever recompiled it without this being stripped. It's pretty easy to work with. So we can do set follow fork mode child run. I should have done continue. Shoot. We'll see if it works still, if I still break. Okay, I broke right on the right. We can telescope note plus 1024. Oh, shoot. Because we don't have the source, it doesn't know exactly what variable note is. So let's see. Telescope RSI plus 1024. Let's see. Maybe x+x RSI plus 1024. See, then plus 8. Is this going to be the canary? Then is this it? I think this is where main is. So we had junk, canary's location, RBP, and then this is the return address. So we got it working. So we could do that minus, shoot, we have to do, let's see. paste that there just so I have it. VMAP. And what is it? I think we are this one. Is that it? Can we do minus? Does GDB work like that? Print? No. Is that it? Let's see. Where is my main? So we're here. Let's actually just continue and see what our program said. Because we should be able to actually do this. I wasn't thinking, but our program should leak main. So return right here. This is before doing anything, so we can just do log.success, and this will be return hex ret hex ret like that. And now when we run this again, we get the return address of, I think, what we had. Oh, I just missed a bunch of stuff. I should have been doing in like 16 maybe. Python 3 print. See which one's bigger. I think this one's bigger. Minus this. If we do hex, that doesn't look right. Let's try doing VMAP again. We have to run it. And I'm just going to grab this address. I think I grabbed this one before. I don't know why I did that. Let's try this one. Paste it here. And we can do hex. There we go. F54. This is what we want. That looks better. So let's v exploit.py. And where is that one piece? It was like 1.6 we did. 1.6 something. There we go. This e.address is going to be F54. Right? Yep. F54. Okay. So now all that's left to do is stir up the reverse shell, or the tunnel. So pgrep note psef grep note kill note remote pkill note remote. So now we're not listening on the socket, and we can do ssh-i. What is it? What is SSH key? Intense Debian-SNMP, I think, at 10.10.10.195. It's going to go. Yep. So now we can say -L 5001 localhost 5001. We have to do -N as well. And now we can run exploit.py. And if all goes well, it'll work. ID, we are root, hostname, intents. So we did it with the buffer overflow. So we can get root.txt and call it a day. Hope you guys enjoyed the video. Take care, and I will see you all next week.